I would like to talk about my HVAC setup. That is specifically the way that the furnace and the compressor and all of the ducting is configured in the space that we're renting. And so this is kind of a depiction of the home that we're in, and it is a 2-story home. We live on the 2nd story. It's about 950 square feet, 1 furnace and compressor package servicing the 1st floor, and 1 furnace and compressor package servicing the 2nd floor. What I found strange when we moved in was that the furnace was not co-located on the floor that we're on. It was in the basement. This is the basement here. I thought, that's not really that big of a deal, I guess. It's 2 floors. So long as the ductwork is insulated and well installed and properly fitted and all that, it should be fine. The first few months we lived here about 2 years ago, it was pretty warm, and the air conditioning struggled mightily to keep the temperatures down. The air conditioning would just run and run and run and run, and it was running probably around 10 to 12 hours a day. It didn't make our electric costs go up that much because we were toward the end of the summer, and then we hit October, and then it just kind of cooled off and it wasn't really a big deal. Last year, it didn't seem again to be that big of a deal because we had some days where it got pretty warm, and I just started working on this thermostat project, and so I had better insight as to what everything was configured to and whether it was cooling properly. And it seemed like it was, but it's just there were a lot of factors at play, being on the 2nd floor, that affected the type of air conditioner that was being used, coupled with the way that it was installed. So let's talk about that. The air conditioner was installed in 2004, probably about 11 SEER. Not exactly sure what the actual efficiency is on it. I've tried to dig into and find as much information as I could about that unit, and I can't find much, given that it is 16 years old. But here's what it looks like, if anybody knows what that thing is and perhaps what its efficiency might be or any more information on it. It's a 1.5 ton unit, I know that, about 18,000 BTU, and it's designed to cover about 1,000 to 1,100 square feet in normal conditions. I say normal conditions because we're in 950 square feet, which you'd think, well, that's well within the coverage range. We have a kitchen, and we're also on the 2nd floor, so we have the solar loading from the sun, not only through a bunch of windows that we have, but also the roof. And so there's sufficient venting on the roof, and there's gable vents and all that stuff. So it's not like it's incorrectly installed or anything like that, or some massive deficient thing here. But it seems like it's more of a situation of the furnace being on in the basement, and then uninsulated ductwork running up a whole floor, and then coming up to this space, where we're at. And then there's the red is the cold air return, but since we're talking about summer and the cooling season, I made it red because it's the hot air return. It's being pulled back into the furnace through the evaporator and back through cold registers in this season. Last year was okay. The air conditioner definitely ran probably around 35 to 40% duty cycle the days that it got kind of warm. But we really didn't have sustained heating days where it was repeatedly in the upper 80s or lower 90s with full solar loading. That is, the sun is out all day until this year. This year so far, wow, the air conditioner has struggled. Again, we've checked the air conditioner out and it's actually operating fine. It's being pushed beyond what it was designed to do in an application that it was already kind of right at the edge of what its capabilities were. So we're talking about, in the last couple of weeks, the daytime temperatures being between 86 and 94 degrees Fahrenheit, and the nighttime temperatures between 68 and 76. I think the last thing I'll mention about the house is that it was originally built in 1890s. This is an older home that was renovated in 2004, which is why all the appliances, including the furnace and the outdoor unit, are from 2004. And again, we're renting, so I have no desire nor inclination to replace these things unless they're defective, and then I'll tell the landlord, hey, you've got to replace them. By all accounts, I've not seen anything to indicate that with a lot of the measurements that I've taken. What were the indications that I noticed that there was something up with the air conditioner this year? So the first thing I noticed was longer run times. So the air conditioner typically will run maybe like a half an hour to 45 minutes per cycle, which may seem long compared to perhaps what some of you have in larger homes with 2-ton or 2.5-ton or 3-ton air conditioners that are purposely oversized for the application to account for heating when you're cooking, or solar loading when it's really hot outside and you want to keep that upper floor cooler. So this one definitely, again, is just right at about the edge of where it's not undersized. And it's not like we're freezing out the place. So our highest set point is about 78.5, and the lowest at night is about 74.5, with the average around 76. The other thing that was very noticeable was the decrease in humidity, massive decrease in humidity. The air conditioner should be running and aiming to maintain the humidity at somewhere between 50 and 55%, and not dropping it below that level, because air conditioners essentially are dehumidifiers. And so what is interesting is that we started seeing the humidity drop from 42% down to 38%. And that is a pretty sizable drop. And when the humidity starts to drop that noticeably, especially when it's been running for that long of a period of time, it's not low enough to really be super annoying, but you can kind of tell the air feels dry and it's just not as pleasant. The other thing is that you're not maintaining enough humidity in the air to help the evaporator. Here's my little evaporator image here in the furnace. Oop, there we go. There's my little furnace picture down there. But the furnace is doing nothing, obviously, in the middle of summer. But what it is doing that's contained within the furnace is there's the blower. And the airflow goes up into the evaporator, which just sits on top of or below or next to, depending on how your air conditioner is configured and where it sits in your house. But there's basically like a V-looking thing with a bunch of fins on it. And that is designed to have some moisture on it at all times to maximize energy transfer. So you get the maximum amount of heat being extracted from the air. Once it becomes completely saturated on those coils, not frozen, but saturated, then the excess drips down into a collection area, and then it drips into a little tube and goes into your floor drain or wherever that it goes to in your home. So this was surprising. And when I noticed this, and the thermostat also was picking up the fact that the humidity was dropping and warning that it was going below 40%, then the run times would just climb. The change in temperature over time would fall to almost nothing, to zero. Okay, another concerning thing. So that would drive up the run times even more cost and energy. So the third thing was that it wasn't hitting a reasonable set point. If it was 76 degrees outside, air conditioners have about a 20-degree range, so from outdoor to indoor temperatures. If it's 76 outside, the lowest air conditioner can really get down to is probably like 56. And I'll even round that up to 60, because again, getting it down to 56 in your house is going to take quite a long time to get there, even with a really powerful air conditioner. But 60 degrees, and it would sit and not get close to 74. It would be running and running and running, and eventually would hit it after sitting for about 2 hours. These three things plus all contributed then to a duty cycle of somewhere between 40 and 45%. And that'll jack up the electric bill. So that gave us some cause for concern. So I was looking at room air conditioners, like a 5,000 BTU AC to supplement the main air conditioner. Those are about $200, even more. And then I was thinking, well, maybe 8,000 BTU. There's a lot of things that I was considering. And then I saw an ad for a personal evaporative cooler. Yeah, I know. So I saw an ad for a personal evaporative cooler, and I was like, okay, they're inexpensive. This one was actually for an Evaporative brand. And I thought, these things evaporative coolers are great for the Southwest and for the desert areas and areas where it's dry, but here in the Midwest, it's just not gonna work. But something told me to purchase one and just try it to see if it worked and to see what actual cooling performance I could get. And more importantly, I knew that they acted like humidifiers because they release humidity into the air. And so if I could just replace that humidity in the air that's being pulled out by the air conditioner operating properly, but just running at a really high duty cycle, I could introduce humidity into the air at a cool temperature as opposed to like boiling water, because then you're just putting heat into the air, that it might cool the air down a little bit, personally cool down the air where the unit is at, and then also contribute some humidity to the environment, raise that level back up, which then helps the evaporator operate more efficiently, reduce the runtime, and then reduce the cost of operating the air conditioner. It's kind of a win-win-win. Basically, what is an evaporative cooler? Really quickly, you're pouring some water into a tank. The tank goes into some sort of evaporative pad or filter, and you're taking liquid water, and it's the process of evaporating it into a vapor when it goes through that phase change, it uses energy to go between those two phases. And so by doing that, that energy comes from the ambient air and it lowers the temperature of the air. Now the air then comes out of that process slightly more humidified. And so there is an increase in humidity. But if you're running it with your air conditioner, the air conditioner, if it's operating properly, should easily remove that little bit of moisture that's being put into the air. So the Evaporative claims 340 to 1120 BTU per hour, up to 1230 BTUs per hour if you're using their newest unit, the biggest unit that they make. They have 3 in their product line. That's somewhere between 100 watts and 340 watts. I think this goes a little bit higher than 340 watts for the highest BTU per hour. Now the input to the Evaporative unit is about 5 watts. That's it. It's powered by USB. That's with a couple of conditions being met. So long as the relative humidity is not greater than 70% and that your ambient temperature is not less than 70 degrees Fahrenheit. What I noticed is that with the Evaporative, the intake temperature was about 79 degrees Fahrenheit. That's the air coming in from the back of the unit. And then the exhaust was about 70 degrees Fahrenheit, sometimes dropping to 68 or 66. So that would give us a delta T of between 9 and 15 degrees Fahrenheit. Now I used what was on the unit, but I also double checked it with an infrared thermometer and it checked out. So what that resulted in for me was about 730 BTU to about 830 BTU per hour. So I wasn't getting the maximum, but I wasn't expecting to because I'm not in an area that is super low humidity and super high temperature. Once I turned this thing on, I was able to see in the thermostat that it wasn't cooling down the room, but it was slowing down the rate of heating. So it would drop from about 0.03 degrees Fahrenheit per minute temperature increase. It got to like around flat, depending on the time of day. And because it's running continuously, this is 730 to 800 BTU per hour continuously. Your air conditioner may be 18,000 BTU or whatever. It runs for a period of time and turns off, runs for a period of time and turns off. While it has surge cooling capability way beyond what this can do, this actually has an effective amount of cooling ability to remove heat from the air and keep an area around you comfortable. It did raise the humidity a little bit. Every 2 hours, it would probably go up about 2% relative humidity. And once the air conditioner kicked back on again, it easily dropped that right back down to 50 to 55%. So let's get some data here. Down at the bottom here, I have 2 sides just to talk about some preliminary data that I got from the thermostat logging. And I took 3 days before using the personal evaporative cooler, in this case, the Evaporative unit, and 3 days after using it. I took 3 days that I found in the log data that were as close as I could find to one another. The average high temperature of the 3 days that I took in the sample was 87.8 degrees Fahrenheit, the low was 64.9, and the average was 80.8. On those 3 days, the air conditioner ran 39.4% of the time, or about 9.4 hours per day. The 3 days after, when the high temperature was 85.3 and the low was 70.1, the low was actually higher than these previous days, and the average temperature was 78.8, so a 2-degree difference between the average samples. The average runtime was 26.8%, and the hours per day of runtime was 6.4 hours per day. That equates to a 12.6% drop in duty cycle and runtime, and that is a remarkable improvement. Plus, you get to be a personal cooling area when the air conditioner is not running, and you get a little bit of humidity added. So a 12.6% drop. This is preliminary testing. I had to get something to show and to see if this is making any sort of improvement. And I have to say, as I'm making this video, I've been using this for many more days afterwards, and it is showing major improvements in the air conditioning runtime and the overall comfort level in our place. When you consider the fact that you're putting about 5 to 8 watts into this unit and getting about 200 cooling watts, so right down the middle, which is consistent with like around the middle of the BTU per hour output, 200 watts per hour over 5 watts in. So that is an energy efficiency of 40. So the EER, energy efficiency ratio, is 40. This is an amazing efficiency. And combine that with the fact that I'm using this thing with a battery pack like this one that's charged by solar. You're getting as close to free energy as you possibly can. And you can turn a 50, like that one's a 50 watt hour battery pack into a 2 kilowatt hour battery pack. Overall, I have discovered that personal evaporative coolers work even if you're using them in a home that's in the Midwest and it's humid outside, but your inside is air conditioned. It gives you the ability to reduce the dependency on the air conditioning and reduce its runtime and things like that. Granted, if you have a really high efficiency air conditioning system, this is moot, but I'm operating with something that perhaps many people do have, which is 10 to 15-year-old air conditioning systems, and you're not looking to replace them, and perhaps you want to help save some money. You can help contribute to reducing the runtime on the air conditioning. Let's talk about the two different units I'm testing. One is the Evaporative EV1500, and the other is the, as seen on TV, Arctic Air Ultra with 2 times cooling power. I just wanted to share that evaporative coolers do work, but it's very important to consider what type of evaporative cooler you purchase, and if it is a company that actually designs something that works, or it's something that is misrepresenting technology and is basically a scam trying to get your money. And that's not just for evaporative coolers, it's for a lot of different products that are out there. So that's why we're going to talk about these two. Basically the most expensive personal evaporative cooler that you can find and the cheapest evaporative cooler that I could find that seemed legitimate. I saw plenty that were cheaper, especially on Amazon and eBay, and I looked at the filter material and I was like, there's no way that could potentially cool anything. There were some that I saw that had this shape, they had pictures of it, and you could sort of see inside, and they had pairs of filter paper. There's only like 8 or 10 sheets of that. Here's the Evapolar filter, crazy. And then here's the as seen on TV filter, which looks less amazing, but there are important additional things that are inside that Arctic Air Ultra that make it more efficient, and so it doesn't need as much filter material. But if you compare that to something like this, you can start to see where, like, definitely one of these things is not like the other. That sort of thing, I think, is what I'm hoping to suss out. Finally, just like compressor-based air conditioning that most of us are all familiar with, there are limitations to this evaporative cooler technology as well. I don't know why I'm pointing at that thing. That thing's definitely not going to do anything. If you're living in an area where you don't have air conditioning and it's humid, and you're going to use one of these things to try to cool your home or even cool an area around you, it's just not going to work. If the relative humidity in the air is above 70% or the ambient temperature is less than 70 degrees Fahrenheit, it's not going to give you much cooling efficiency at all. In fact, it may actually make it feel hotter because it's going to introduce more relative humidity, thereby increasing the heat index, thereby decreasing the ability for your skin to evaporate sweat. So yeah, these are coming up. If you like what you saw, like and subscribe, and I will see you in the next one. Take care.